Good afternoon, everyone. So as Shankar mentioned, we will continue the morning session in this afternoon as well. So in the morning, we covered some areas of WSO2 Integrator as well as Devant. So in this session, we will specifically cover the file integration things. That is how we can read files from SFTP locations and then process those, and also data access. And then we'll go a bit deep into Devant, that is our iPaaS. Then Rosen will cover the AI stuff, specifically how we can build RAG applications, as well as micro-integrator related things. So I'm Chathura Ekanayake. I'm Associate Director and Architect in WSO2. So in this first part, so this is the outline. So we'll continue the same use case that Tariq and Mariam discussed in the morning. So basically, we are covering different scenarios, integration scenarios in a super retail chain. Basically, we call it O2 Mart in this case. So in this scenario, we will consider this situation where we have multiple outlets of this retail chain. And at the end of the day, these retail outlets send their daily sales data to a central SFTP location. So this data will be sent as CSV files. Then we need to have an integration deployed in the central data center, which basically listens for this SFTP location. And if there's a file, it should get the file and then process the records and then store those in a database. So this is the simple scenario that we do. So again, like we show how we can do this in Ballerina Integrator, which is the on-prem product, integration product in WSO2, as well as how we can deploy that into Devant. So again, when we discuss this deployment, so these are the scenarios that we do. So first we do this topmost one, which is we deploy this scenario in BI and then test it in the local machine. So this is somewhat equivalent to doing this in an on-prem data center. And for this on-prem scenario, we have a set of configuration values, because in this scenario, we are connecting to an on-prem SFTP server, as well as we are connecting to a database hosted on-prem. So these credentials and URLs has to be specific to this on-prem environment. So we will see how we can use these configurations specific to the environment, and then we will push this code to a Git repository, and we will show how we can deploy the same code into the cloud environment as well as how we can migrate this same integration between different cloud environments by just changing the configuration values. So this is the scenario. So I will first go to VS Code plugin for Ballerina Integrator, BI. So we will start a new project. So we want to first create a new integration. We can give any name. So let's call it sales files. So this is the main screen that we get. So here we can add multiple integration artifacts. So we can create automation, we can create HTTP services, we can have event handlers listening for message brokers, as well as we can create file integrations, which are the integrations that listen for file locations. So in this particular case, we want to listen for a SFTP location. So let's click on the SFTP service. So we can give, first it asks us to configure the file listener. So let's give a name for the file listener. Let's call it just file listener, something like this. Then we can configure the parameters for this. So protocol in this case, it suggests different options. So in this case, it has to be SFTP because we are connecting to SFTP location. Then it asks other things like host, port, authentication details. So for these things, we can just give the value, literal value itself here, but also we can just give a configurable value, which can be configured based on the environment. So because we want to deploy this into multiple environments, it's better in this case to have a configurable. So when I click on this, it gives the suggestions, as well as I can click on the configurables and add the configure location as the host. So I'll create a new configurable variable. So let's call it SFTP host. So the type of this is string. Okay. Now it creates the configurable. Then it is added as the host. So basically, we are not giving the value, but we are just giving a configurable variable here. So similarly, we can do the same for other things as well. But let's say that port, we are hard coding here, just for this case. And then it asks us to give the authentication method. So there again, we can have multiple options. We can give username and password, which is the credentials option. And if we have configured our SFTP server to use private and public key-based authentication, we can go with this option. So in this case, we are using the credentials-based option, authentication method. Then again, we have the option of giving configurable values for these username and password values as well. So let's do it. So we have created the configurable value called SFTP user and assigned it here. So because we are using a configurable value, do it like that. So similarly, we can have a configurable value here as well. So just for now, let's give something, and then we can create a configurable value later. Then we have to give the path to listen to. That is like so in SFTP server, there can be multiple folders, and we can specify to which folder we should listen. So in this case, it is the upload folder. Then again, file name pattern we have to give. So that is like if you are only looking for JSON files or CSV files, then we can give the pattern for that. So I'll just copy the file name pattern from here. Right. Okay. Now we have configured. Then again, we have to configure the polling interval. So that means this SFTP listener basically polls the given STP location periodically, and then get the new files from that location. So we have to give the polling interval there as well. So let's give it as 3 seconds. Now we have configured the listener. Now we can create the integration based on the file listener. Now there's only one method in this listener, this file service, that is on file change. So when I click on that, I can associate the integration with that event. So first, we will not build the entire integration. We will just see whether it works. For that, we can simply log the details about changed files. So here you can see that we get the event, which contains all the details about the event. So in this case, we have a field called added files, which contains an array of files that have been changed. So let's convert that to a string and then log it. So that's it. So we have basically created a very simple file listener to listen on a SFTP location. Now, before checking this, let's go to the file server. So I have started a local SFTP server. So within that, I have this upload location. I'm not sure that you can see it. So I'll delete everything there first. Okay. Now let's start this integration. Okay. Now it says that we have configured some configurable values, but we haven't given actual values for those configurable variables. So to give those values, it asks us to create a toml file which contains these values for these configurable variables. So let's create this one. Okay, so it gives this graphical view of the config toml file as well. So in this case, because I am running this locally, the host will be localhost. And let's say in this case, the user will be just foo. Right. Now we can just see the config toml file as well. So here you can see that these values have been created there. So basically, this is the file that contains all the configurations. So if you want to move this into a different environment, you just have to change the values in this file, and then the environment will pick values from this file, and then like adjust all the endpoints and other details accordingly. So now we can test this integration. Okay, yeah. So there's an issue because like I have used my own SSH keys. It simply picks those keys from my SSH location, so I have to delete those first. Now the integration is running, but it doesn't print anything because we don't have any files in that SFTP location. Now let's put some files there and see what happens. So before going there, let's see the structure of our CSV files as well. I guess you can see this. So we have 3 files there, SD1, SD2, and SD3. So these are sales data files. So let's check content of one of these files. So those are just CSV files. It has a header which contains shop ID, customer, product, and quantity. And then it has values for these 4 fields. So this is a very simple CSV file. Now let's put one of these files into the SFTP location. Okay, so we are putting this file. Now if you go to the integration, you can see that it has printed some information about the files that we have just uploaded to the SFTP location. Right? Now that's not that much interesting. We are just listening for that location and then printing what's added. Now we want to do some processing on this as well. So let's process each and every of these files and then load that, basically extract fields and then load that into a database. So as you saw, what we get here is an list array of added files. So if we are having such a collection, then we can use the for each step to iterate through each item in that collection. So this is the for each step. So there it asks for the collection. So we have the event, and from the event we can get the added files list. So this is the collection. Then the variable type, here will be file info variable type. Then we have to give the name for these item variables. Now we can simply iterate through this list of files like that. Then within this for each loop, that means for each file, we have to get the content of the file. So to get the content, we can access a stream, basically a data by stream for that particular file using this get method. So path of the file can be taken from the file info object. Okay, so let's call the variable as data stream. Okay, now we get the file content as stream. Then we know that what is in this stream is a CSV content. So we can use the CSV package to pass this into a ballerina type. So for that, we need to have a ballerina type to store these fields. Now, so I think we have covered these types in earlier sessions as well, because basically, if you want to create type to hold different data items, we can go to types and click on this plus sign, and then create records or ballerina records to hold this data. But without going that way, I can also use AI to generate these types. So we know that the headers of this CSV file are these: shop ID, customer, product, and quantity. So we just want to create a type with these fields. So let's ask Ballerina Copilot, BI Copilot, to create these types for us. Oops, we logged out. Let's log in. Okay, now I have logged into BI Copilot. I will ask it to generate types to hold these fields. I'll just say create a type with the following fields. Now let's see what it generates. So it has generated a type file. So if you go inside, you can see the fields that it has generated. So it has shop ID, customer, product, and quantity, and also it has correctly identified these first three things are strings and the quantity is an integer. So we are fine with that. We can add that to the integration. Okay. Now you can see that this type is created here. Right. Now if you want, we can change anything in this. You can go to edit and then maybe change the variable type or field name or anything. But we are fine with what is generated, so we can just keep it as it is. And then we can move back to the integration. Okay. Now here we have obtained an byte stream to the file content. Now we want to pass that byte stream as a CSV type file and then assign that to the type we have just created. So to do that, we can use the Ballerina CSV package. So the call function, we can search for CSV. So under this standard library, we have data CSV package. Under that, we have pass stream method. Right. So here we can give the byte stream. So in this case, it is the data stream. Then we have to give the type to which this values has to be stored in. So this is the type that we have just generated. Then we can give any name for that. Let's call it sales records. Okay, now we have passed that to a Ballerina type array, basically Ballerina variable array. Now, so basically what we have done here is that we can get multiple files in the first stage, because when we listen for a SFP location, we might get multiple files. Then we iterate through each of these files, and for each file, we access the file data as a stream and then pass that as a CSV file. So when you pass that as a CSV file, again we get an array of records because each line in the CSV is a record. So therefore, we can again iterate through each of these records. So we can use the for each again. And in this time, our collection would be sales records. And the variable type will be sales record. So we can give any name here. Okay. Now, just to check whether things work up to this point, we can just print the shop ID from this record and see whether it works. Okay. So let's run this and see. Okay. So you can see that there are two logs containing shop IDs that were there in the CSV file. So if we add a new file, we can see new IDs will also be printed there. So let's add another file. Yeah. So you can see there's another 2 lines printed here for the new file that we have added. So now we have basically extracted CSV content into ballerina types. Now we want to insert this data into a database. Now we have already created a database, MySQL database in my local machine. So database name is salesDB, and we have a table called sales data, which contains these fields. I'm not sure that you can see it. So basically, it has a table with shop ID, customer, and those things that are there in the CSV file. So we want to populate these fields, this table, using the content from those CSV files. So we can simply use the MySQL connector for that. So as Tariq mentioned in the morning session, we have a large number of connectors, and one of those will be the MySQL connector. So we are using this, and then let's call the connection as salesDB. Then we can give other details. So again, similar to the SFTP location, we can use configurables for these things, especially if you are planning to move this across multiple environments. It's always recommended to use configurables. So let's call it db host, and the type is string. And for the user, let's call it db user. Again, type is string. And let's configure this for password as well. So then our database in this case is salesDB, and port is the standard MySQL port. So that's it. We have configured the MySQL connection. If you go back to the integration, now we can simply insert this data into the MySQL database. For that, we can use the connection that we have just configured. And under that, we have the execute method, which basically executes SQL statements. Now here we can type in the insert statement and give any variable as parameters. So to save time, I have already written that statement so that I can just use it. Okay. Now you can see it's just a normal SQL statement. The difference here is that instead of parameters, I have given the variables from the integration. So SD is the content from CSV rows. So from that, I am giving the shop ID, customer, and so on. Right? So we don't care about the result at this point. So let's save it as it is. Okay. Now we have added few more configurables. So that means we have to give values for those as well. So I have again given values for this here. So I can just copy and paste it here. So as you can see, I have given values for these configurables, DB user, DB pass, and the DB host. So we are basically done. Now we can execute and see whether database is filled. Okay. So it says that we have some errors. Let's see what are the errors there. Okay, so it has added unwanted import. Let's remove that. Okay. Okay, now run this. Let's run this. Okay, so it has processed records from both SFTP files that were there in the SFTP location. And now if we go to the database and see, let's see whether those are updated. Yeah, you can see the table is updated with those records. And if I add a new file there, so we have another file, SD3, let's add that one as well. So you can see those are also appended to the table. So that's a very simple file integration scenario. So we can make it complex, like we can do things like we can validate these records, and then if there is something wrong, we can update Google Sheets. So likewise, there are many things that can be done very simply using BI. For example, if you go there, you can see that we have only very few steps in this integration. And also we can extend this as needed to support more complex scenarios. So this is the on-prem scenario that we discussed. So if I go back to the slides. So this is this scenario. We basically read from a SFTP location and then populate a database. And you can see that the configurables, that is the configs for this on-prem scenario, are there in this config.toml file. Now we want to basically move this to cloud as it is. So basically you don't have to do any changes to your integration. You can keep the integration as it is, and then what you have to do is to basically move this to Devant. Devant is our iPlus platform. Okay, so before that I have to push this into a Git repository. So this is my project location. So I'll add this. So I have pushed that into my GitHub repository. So if I go to my repository, you should be able to see it. So this is the BI project for that the scenario that we have just completed. Now we want to deploy this into Devant. So I will go to Devant. So I am not going to introduce Devant because Mariam has already done that. So here what we want to do is that I have already created the organization and a project, and under this project I want to create a new integration. So I click on create, and then I can attach my GitHub location which contains the integration. So I'm using GitHub, so we can use other repositories as well, like GitLab and Bitbucket and so on. Okay. So here I have to select my organization and then the repository. And under this repository, I can select a path which contains the integration project. So the one that we have just completed is demo 5. Under that, this is our BI project. So that's it. Then we have to select the integration type. So what we have developed is a file integration. But if you have developed other things like REST services, automations and so on, you can select the corresponding type. So we select file integration here, and we create the project. So that's all you have to do to move your integration to cloud. Just push your integration to GitHub and then create a Devant project, Devant integration using that GitHub location. So that's all you need to do. Then you can just configure your parameters to suit your cloud deployment. So if now it's still deploying. If I go to build, so it shows that it is queued for building. Now we have to wait until it's built, then it will show an option for us to configure configurables. So until that is being built, I will show a few other options. So here you can see the configured environments. So by default, 2 environments are there, development environment and the production environment. But of course, depending on your tier, you can increase your environments as well. Then for each of these environments, we can configure different parameters. And then our integrations can use parameters from that particular environment as their configurable values, so that we don't have to change code, we just have to change the configurable values. Then if it is a REST service, we can test it from here itself. So because it's not built yet, we can't, it's not shown here. So then also it has observability stuff, like we can look at the logs of our integrations from here. And then matrix. So matrix is basically the values measured about the response time, number of services and so on. So let's see the status here, still building. So it's in progress now. Then we can see the runtime details, like the number of containers that's running for this particular integration. So if I go to the development, so it's not deployed because it's still building. So once it is deployed, we can see those details here. Then we can have these configurations and secrets. So this is useful specifically if you have a database and you want to give username and password there, then you don't want to give that as a normal config file because that can be read by anyone. So you can give those as a secret here. Basically, if you create a configurable, you can mark it as a secret and then give those values. Then also we can configure scaling policies for our integrations. So because it's not deployed yet, we don't see it here. Basically, we can configure whether we want to auto scale it or we want to use the scale to 0 policy, where if there are no requests, it will be eventually shut down and it will be brought up back when there are requests. So that's about the overview of these things. Now let's see. Yeah, now I think it's now its build is complete. Now if we go here, now of course this build, the deployment will fail because we haven't given the configurable values. So if we go here, under the configure, now you can see the configured environments. We have development and the production. Now we have deployed that into development, and under the development environment, we can configure the parameters for configurable variables. So here you can see all the configurable variables I have configured, like SFTP host, SFTP user, and so on. So you can give environment specific values here. Right? Then you can deploy, and it will be deployed into the development environment. Then we can configure additional things, like for example, if you go to so these options are a bit limited for file integrations because there are no policies for requests and so on. So to demonstrate this, I have also deployed a HTTP service or REST service. So there you can see more options that we can do. So here you can configure security for this service. Like you can see, configure whether you want to use an API key or an OAuth2 token. And then it shows all the HTTP operations or resources that are supported there. And for each resource, you can configure policies. Right? For example, let's say that I want to attach scope for this one. So here it shows all the configured scopes. So scopes is a mechanism in OAuth2 which can be used to authorize operations on HTTP services. So here I have configured 2 scopes, grid scope and the sales scope. So I have configured grid scope for this. That means only tokens with this particular scope can invoke this operation in this service. And then I can also, so this is under security. Then if I go back, if I go to configure, so under these settings, we can configure rate limiting policies for this particular service. So at the moment, it is marked as unlimited. Then we can also have API level rate limiting policies as well as resource level rate limiting policies. So if we go with resource level, for each resource, we can have a rate limit. Then we can configure coarse policies, like whether which headers should be allowed and which methods, HTTP methods should be allowed and so on. Then also we can configure the endpoint timeouts for this service. Then under test, because this is HTTP service, it uses this test console. From itself, we can get a test key and invoke this and check whether, how it works. Then under logs, it shows all the logs, but in this particular service, it doesn't generate any logs. Under matrix, we can see all the measurements that we have measured against this service. let's. It seems like I haven't invoked this for some time. Yeah, so you can see the request per minute and request latency for this service, and then if you go down, you can see memory usage, data received and data sent. So all these metrics will be displayed here. So that's it. Basically now, if I'm satisfied with the development environment, then I can go here and promote that to the production environment. And then in the production environment, all the production configurations will be applied. So that's basically it about the file integrations, data access, and Devant. So if there are any questions, I can take it now. Then yeah, we can hand over to Rosen.
Okay, sir. Good evening. As Shankar mentioned, I'm Rosen. I'm heading the micro integrator team. So, in the morning session, Tariq, Mariam, and in the evening, Chathura discussed about all the Devant and the BI. So, this component is micro integrator component. I'll just cover in a high level what the micro integrator does and how does that fit in this Devant story and the integrations strategy of WSO2. So basically to introduce MI, so it's if you are already using it, you might know. Otherwise, so basically it's a battle tested integration runtime introduced few decades back, and so basically it's a lightweight and cloud native runtime. So if you have used WSO2 Enterprise Integrator or ESB, so it's the evaluation of that particular product, lighter, more lighter and fast product. So basically it features all the built-in mediation engine that supports 100% EIP pattern using based on Apache Synapse, and all the legacy protocols including SOAP, WSDL, and all the HTTP, JMS, RabbitMQ, everything is there as well. So the latest addition is like now we have AI assisted development experience in MI as well, and also now we have built-in observability and Devant capabilities in MI as well. So development experience is more or less the same. So we have a same kind of a UI for micro integrator as well in VS Code. So it has built-in AI Copilot, which was built from in-house at WSO2. So that's different from GitHub Copilot or VS Code built-in Copilot. This is MI Copilot is there to develop integration artifacts. And from the integration VS Code editor itself, we can run, debug, and test the integrations. So I'll briefly cover what are the new features we have added in our recent release. So basically this is a very high level introduction. We have covered that earlier. If you need, that's there in our resources, libraries, WSO2. So basically with the latest MI release, we have introduced new Synapse expression language. So basically we had earlier Synapse XPath, and then we need to use JSON path and XPath to use integrate, so to basically navigate through the payload and so on. So to make it easier, we have introduced new Synapse expression language, and also now we support Ballerina module in MI. So that is the bridge between those two products. Basically, micro integrator has been there for few times. So now Ballerina integrator, you can develop integrations, more complex integrations seamlessly. So you can use that integration platform and then connect to existing MI using this Ballerina module. And then we have improved our existing WSO2 mediators, and also we have added environment variable injection as you've seen in the previous sessions. that we had this configurable option. So now that's there in MI as well. And we have recently added the gRPC support. Basically, you can call to gRPC services from micro integrator. So this is how the new Synapse expression language looks like. So you can access payloads using payload.user, and then we have variables to store data. So you can access using var.variables, and you can write quick expressions, conditional checks like this, was.age equals greater than 18, and so on. So likewise, and then we have graphical support similar to in what you show in Ballerina integrator is there for MI as well. And then this is the Ballerina module that I explained to you earlier. So you can write Ballerina code inside the micro integrator plugin and use it as a mediator in the WSO2 MI. So basically, you can bring back your Ballerina complex code, whatever you've written to do complex data manipulation, and you can run it inside the MI. So you can add it just as a mediator and pass the message to that mediator. So basically, in Synapse, this micro integrator is based on a data flow model where you start with a payload and it flows through the set of mediators. So now that data object we can pass to Ballerina module. Then you can implement whatever the Ballerina logic you need and then get the result back from that. And these are the mediator improvements that we did. Like we had earlier clone aggregate as 2 separate mediators, and we have improved it drastically using a new mediator called scattergather mediator, which does the cloning and aggregating at the same time. And then we have added the variable mediator to easily manage the variables. If you are used to micro integrator or ESB, there are a lot of occurrences of property mediator because you need to store everything in the properties. So now we can easily maintain it as a variable. And yeah, this is the variable environmental variable injection that is configurable. So in the Synapse itself, you can mark these variables as configs dot something, and then that particular thing you can inject according to your variable environment. So that's a very high level recap of MI, what we did in the last release. So coming back to today's session, so if you were there in the morning session, we started this session using a use case of the O2 Mart, which is a shopping scenario. So I'll now cover how RAG or retrieval augmented generation helps in modern integration development. So basically here, as you can see, now we have our shopping web application. So now say your O2 Mart sells electronic items like laptops, TVs, and etc., mobile phones. Then usually people come back and say, I want to return this item, so what is the return policy? So we have seen this kind of use cases in this particular retail environment. And also product help. If you buy a new TV or something like that, there's a huge manual or something like that to get help. So there are like separate help desks operated by certain vendors to help customers. So now with the AI, I think those are the areas we can drastically improve using Gen AI. Because when it comes to Gen AI, earlier we used to integration, in integration we used to work with structural data. We know the structure, then we can write programs for that. So now with the unstructured data, we can do integrations. Unstructured data is easily understandable by AI. So if we provide the unstructured data properly to the AI, and then with the same integration logic, you can easily integrate this AI capabilities to your existing integration. Basically MI or BI, if you have already integrations there, you can simply integrate AI capabilities to existing integration. Because in the integration layer, you match all the data and the protocols and everything is there in your integration domain. So you can easily harness this value of AI or this unstructured data using this concept. So that brings us to the RAG pattern. So talking about RAG pattern, I think most of you might have already heard about RAG pattern. I'll try to just cover briefly about what is RAG pattern. Basically, in GenAI, we have pre-trained models hosted in OpenAI, DeepSeek, Azure, or somewhere like that. That is pre-trained using a vast amount of data, not specifically but your organization data or something specific to your domain. So that is more general training happening in the OpenAI servers. So say in this example, if your product, if your WSO2 Mart company wants to more detail about your specific product, what are the return policies of those products, and that data we need to store somewhere, similar to databases in structured data. So in databases, we have the database, we store using our names and so on, and then we query using select queries, something like that. In a GenAI world, this database is what you call as vector database. So that is the database you are going to keep your unstructured data, and when you are retrieving it, you get it from a certain vector. So basically, RAG pattern is like you have a unstructured data, you put it into database, and you can retrieve that data using similar, we don't need to use the same query that you used to give to SQL kind of thing. Because now in AI, if you say you save it as a cat or something like that, then you can retrieve it using pet, because it understands the context. So then we'll see how so RAG pattern works in integration. So basically, we user inputs a query to our integration. Then we can search documents where it matches the semantic meaning of that particular query. And we can use that data to send back to the LLM, like OpenAI. To OpenAI, we need to send our query plus the knowledge that we have about that particular query. For example, in this use case, if it is a TV and the return policy document is the PDF, for AI, OpenAI, you need to send that particular TV PDF and the user query. I want to return this malfunctioning TV, what do I need to do? And for AI, you need to send that query plus the document. So that's what we are going to now see. I'll show you in Devant how we can easily build that database or the RAG database using our Devant infrastructure. So this is the Devant, our iPaaS solution. So in here you can see there's this admin. Inside the admin we have basically in our iPaaS we can support databases, vector databases, and message brokers, etc. I'll choose this RAG ingestion option. So here, as you can see, there are like common vendors for maintaining this AI database or RAG databases. So Pinecone is one of such a large vendor that is SaaS software for RAG-based application, and ChromaDB, and then we have few other RAG types as well. So I'll show you using Pinecone how easily we can populate our vector database. Now in this example, I have for Pinecone I need to give Pinecone keys and collection name O2. So now I have given the vector database API keys and details, and then I need to give an embedding model. That's where this embedding model is a large language, kind of a large language model, where it can extract your information and give the particular vector, so that when you are retrieving back, you can easily get it from the same kind of a vector, because LLM knows about the context. It generates a proper vector. So against that vector, we are storing in our database. So to get that vector, we can use Mistral AI, Azure OpenAI, or OpenAI models. So in OpenAI models, there are a few models that can do that. I'll choose the OpenAI embedding 3 model. And for that, I need to give the API key for the OpenAI. And once I have completed that step, now it asks for the strategy. So basically, you can keep the default value as it is if you are not if you don't have expertise in this area. But if you do, you can change these parameters and see how you can improve your RAG. So now here comes the data ingestion part. So whatever the files you have, you need to get the knowledge. You can upload all your files here. So for this demo, I have added some samples. So this RAG folder will have, say, LG. So these documents you might already familiar with. So this has a lot of unstructured data where it explains what not to do when that washing machine goes wrong and what to do and so on and so forth. For a TV, so what is a return policy, what needs to be done and so on. So we can add all these documents related that in this use case, we have O2 Mart. In the O2 Mart, say if you have 1,000 TVs and 1,000 mobile phones, you have 2,000 PDF files. You can add all those files to this Devant RAG ingestion pipeline. So I'll add all these documents and then upload. So it will upload to a SaaS provider. If you worried about your data security and so on and so forth, you can of course do it in the PostgreSQL, inbuilt databases as well. So for the demonstration purpose, I'm using the most famous RAGwin. Okay, so it will upload file by file. So of course you can write event listener as well to listen particular folder location, as Chathura explained in the earlier slides. So you can easily use a file listener in Ballerina or Micro MI, and then you can use that to ingest to the vector database as well. That which is already always there for more fine-grained RAG ingestion. So now I have uploaded all the files. If I click next, I can test this RAG ingestion whether it was successful or not. Yeah, it retrieved data successfully. So if I go to the Pinecone one, now you can see that data is added to this Pinecone software. So here you can see our data is there as chunks now. So you can retrieve whatever, say if you request about Samsung TV, it will give this document from this Pinecone vector database. So let's see how you can get that data as well. So here I am going to demonstrate this RAG retrieval part, basically from Micro Integrator plugin. So similar to BI plugin, we can create the projects in MI plugin as well, and then I'll create a post request to get return policy. I'll change this to post request, and then here now I need to retrieve data from that vector database. So I need to have AI module here. So I can download the AI module from the connector store. So now it's there. So this AI module in MI has this chat option, RAG chat and agent and knowledge. This is where I explained you about how to add to knowledge and how to retrieve knowledge from MI directly without using Devant. Also you can add to knowledge using our file listeners. And then of course we have this RAG chat option. So in this RAG chat option, you can create the embedding model connection first. So I'm using OpenAI connection. I'm using the same key here. So for vector databases, now I'm going to use the same vector database that I have populated using Devant. So that is based on Pinecone. So I'm going to select Pinecone as the vector database and then give the connection name. So here I'll demonstrate how I can use our config option to externalize API keys. So basically here you can go to the config similar to what you show in BI plugin. So there's this option to create new configurable. So here I can add Pinecone. Pinecone API key and select that as the API key. And here I'm using this vector database index as what I have created as O2 Mart demo. And then I can add that connector as well. Now, since I have added that connection, I'll need to add that value for the environment variable as well. Okay, now, sorry, I have to add the. So here I am going to select the AI connector and Pinecone connection, and for LLM connection also the same connection we can use because both are in the same OpenAI vendor. So this is where I need to write the query. Basically, I can since this is going to be O2 Mart service, I need to program this to act as a AI helper for your return policy. So I need to instruct here our AI assistant think you as the return agent. Think you as the O2 Mart sales agent and answer the user queries. So now the user query, I'm going to add it as a, so it will be coming for the this flow as a request. So here I need to pass the user query to this prompt. So how can I do that is like I can go to the expression editor and write an expression to get that value from the payload. So say I have a payload. In the payload I have a query. Says I have a query. I can add it as the payload.query. So in the payload, if I in the REST post request, if I send a query inside the payload, it will come to here and send back to the LLM. So that's all you need to do to configure this RAG chat. So here, since it's a data flow object model, so they started with a request and then it flows through the mediation. So I'm going to use this option. Otherwise, the main body will be the what you get in the request. So I'm going to replace the message body using the AI result. So then I can simply add a response mediator to send back to the client. Now the message body we have changed from user request to the AI result. So once this is done, basically you have integrated the RAG application. So I can run it here. So in the VS Code itself, we have the built-in MI runtime and everything. You can run and see. So yeah. So I have added that as a query, and then I say I need to return my So if say user ask this kind of a question from the O2 Mart website, what is the return policy of my Dell laptop? It will go through this integration layer and get the relevant data from the vector store and respond back, add to that to the LLM and get the feedback and then send back to the user, end user. Yeah, there's an issue in the AI Pinecone connection, maybe. Yeah, I'll switch back to the, I have already prepared the use case. So, yeah, there's a Pinecone connection issue there. So, this one, okay. So, here you can see now the response is from the OpenAI to return your Dell Inspiron laptop purchased from O2 Mart. You need to do this, and you can contact this phone number. Everything you retrieved from the document that we provide. So, this RAG agent will give you the sources as well. So, these are the sources that it took this information. In our Pinecone registry, we have this information. So, it has retrieved those information from the RAG and provide a proper answer for this one. So, as you can see, you can easily integrate these AI features to existing integrations, because it takes, say, within few hours you will be able to implement these kind of features your existing integration flows. Basically, yeah, because in integration we have everything that you need, all the files and all the store details and everything you have. So rather than going to a separate AI vendor, it's easy for us to do it in the same integration layer, because AI is mostly like calling through networks to LLMs. Like integration, it's a integration use case basically. So yeah, so that's the AI RAG flow part, and then so here also you can, as Chathura mentioned earlier, from this to cloud, you don't need to do much here, because all the existing Devant features are available in both MI and BI plugins. So what you need to do is like go to the home page, and then you can see here the same options are available in this platform as well. You can deploy it into Devant using a single button click. For that you need to add this project to GitHub. From GitHub you can, from the click of a button, you can send this project to the cloud. So yeah. So that's it for the micro integrator and the RAG part. So we are happy to help answering any question you have for any session from the morning session up to now.